In this video, we'll be discussing the solutions to our latest review quiz. So for the first one, we are asked to find dy du. And we are given a couple of things about y and u. So the first thing we need to do then is to find dy dx. And so dy dx, that's going to be 2x. And then we need to find du dx, and that's just going to be 2. And so what we need to do now is realize to get dy du, then we will be doing some dividing here. So we're going to do dy over dx divided by du over dx. Let me get my pen going here, sorry. So du dx. And notice those dx's do cancel to have dy over du. So this implies that I need 2x over 2, so that simplifies down to be just x. So we have answer choice D. Okay, for our next problem, at x equals 0, which of the following must be true of the function defined by what we're given, which is a bunch of mess. And so let's look at our answer choices. So notice we're talking about increasing, decreasing, some discontinuous, relative min, relative max. So it would be a good idea to go ahead and find maybe f prime and see what's going on with f prime at 0, and that should help us. So let's see, f prime of x in this problem. Well, let's see, the derivative of x squared, we have 2x. And let's see, the derivative of e to the step is going to be step prime. So the derivative of negative 2x is negative 2. And then we have e to the negative 2x. And so let's look at what's going on at f prime at 0. Well, let's see, that's going to be 0 minus 2. So f prime at 0 is less than 0. So that tells me there, if my derivative is negative, then f is decreasing. So that's going to be answer choice B. Right, number 3. The way number 3 is set up is saying that we took the derivative and we got tangent. So what was the original function? And so we can set this up as we have dy dx equals tangent x, and we can separate this and do some integration. Excuse me. So I have tangent x dx, and then we can integrate both sides. And we can integrate over here, tangent x dx, and so we have y equals. And if you're not sure about what that's equal to, you can always say, well, definitely not cosine, that's crackhead. Sorry, I'm a crackhead some days. So we have sine x over cosine x dx, and we can do a u sub here and let u equal cosine x, and du would then be the negative of sine x. And so notice that we're getting the integral negative of 1 over u du, which is negative natural log of the absolute value of u, which is cosine x. Now, and then of course plus c, don't forget plus c. You go to places that you don't want to if you forget plus c. So here, looking at our answer choices, we're very tempted to choose D, but notice D does not have the negative in front of it. So we have to think about our logarithm rules, and what does it mean for that negative to be up front? Well, really, we can move it up here and become an exponent, which is then going to tell me I need the reciprocal of cosine, which is secant x. So it looks like that's going to give us answer choice C. All right, number 4 is a very strange problem at best. We are looking for the value of dy dx, but the problem is we are given y and u u and v, and then v and x. So I'm going to have to go through and really do some rewriting, some really different stuff here to try to get what I need. So let me erase all those little tick marks because I don't like it. All right, so let's see. If v is equal to the natural log of x, then that means that u, we can go sub in here. And so we're going to have u equals v, which is going to be natural log of x, minus 1 over natural log of x. And so from there, then we can go back and substitute that in where I see a u. So then that gives me y equals tangent of u, but u is the natural log of x minus 1 over natural log of x. So now I've got y and x together. Now let's try to find dy dx. And so let's see, dy dx equals, and let's see, the derivative of tangent u is going to be secant u. So we're going to have secant natural log of x minus 1 over natural log of x. But then it's also times the derivative of the angle. Well, the derivative of the natural log of x is going to be 1 over x. And then we have to think about this. Well, that's really minus natural log of x, right? And so, gosh, that's going to be all raised to the negative 1. So we need chain rule here. So let's see. I'm going to multiply this down. So I'm going to have plus, and then natural log x raised to the, well, let's see, I've multiplied down. All right, so subtract 1, so that's the negative 2 times the derivative of the inside here. So the derivative of natural log of x is 1 over x. Holy good gracious, that's crazy. So let's see if we can pretty this up a bit. So I have dy dx. It's going to be secant the natural log of x minus 1 over natural log x times 1 over x plus, and all of that crap is going to be x times natural log x. Sorry, not crap, awesome math stuff. Now I need the value of all this awesome math stuff at e. So we have dy dx evaluated, where do we say at x equals e? So we're going to have secant, well, natural log e is 1, hallelujah, minus 1 over 1 times 1 over e plus 1 over e times 1. Well, all right. Well, that's a little bit better. So that's going to give me secant of 0 times 1 over e plus 1 over e. So secant of 0, I'm pretty sure most days is 1. And so I have 1 times e plus e, or 1 over e plus 1 over e. Thank goodness we have a common denominator. So that's going to be 1 times 2 over e. And I think we found the answer here. It is going to be, drum roll, D. Yay! All right, so for number 5, goodness, 5 looks horrible, and it looks like a good old classic integration by parts. So let's see, what in the world can we do with this? Well, I would try to get f of x by itself on one side since that's what I'm solving for. And if we try to do that, then we're going to have to add that whole integral over to the other side. So I'm going to have f of x equals, and if we move this over, we have the integral of x squared cosine x dx plus the integral of 2x sine x dx. All right, and this looks like we need some sunshine minus voodoo. So let's see what we can do with this. So sunshine, so we need some and we need some UV minus the integral v to u. And let's see, I would let u be x squared. And then du is going to be 2x dx. And then we need to assign a dv, which then would have to be cosine x. And if we integrate cosine, we're going to get sine x. So, let's see what that's going to give us before we encounter the other, definitely. So when we put this together, and again, remember it's UV, so sunshine, so we have x squared sine x minus the integral of v du. Ooh, voodoo. So sine x times 2x dx. Well, all right. Well, that's that part integrated. But look at what we also have. We've still got to bring down this portion here. So if I bring that down here, well, this is kind of a nice little surprise, because what happens is we have plus the integral of 2x sine x dx. So notice that, notice that that x looks horrendous. Let's fix that for sure. All right, so notice that this integral and this integral are the same with sign changes, so they're going to cancel each other out. Well, hot dog, so that means we have x squared sine x. And so that, oh, and plus c, don't forget plus c. So that means we have answer choice B. All right, number 6, yay. Have an easy problem for a change. We're going to be integrating here. So if I integrate this awesome little problem here, and we all hope to always get this. So it's going to be x to the 4th over 4 minus 3x squared over 2 plus c. And that looks like it's going to be answer choice E. All right, number 7. Number 7, we're going to have some u substitution and adjust some endpoints here to make life easy for us. So with our u substitution, notice that if we take the derivative of x squared plus 2x, well, that derivative, let's go ahead and just write it down here. U equals x squared plus 2x. So du is going to be 2x plus 2 dx, which is mighty close to what we need up here. We just need to factor out a 2, and notice we do have that x plus 1 there. So we need to balance our u sub with a 1/2. So we're going to have 1/2. And I would go ahead and adjust my endpoints also, just to make it easier for us. If we take our first endpoint of 1 and substitute it in, that's going to give us, let's see, our first endpoint, if we change it out, we're going to get 1 squared, so 3, and our other one's going to be 0. And let's see, then we're going to have e to the u du. And so we can go ahead and integrate that. So that's going to be 1/2 e to the 3rd minus 1/2 e to the 0. And that looks like that's going to give me, let's see, it looks like they factored out the 1/2 here. So we're going to get answer choice B. All right, now we're looking for dy dx. So let's find, the first one we have is dx dt is going to be 3t squared minus 1. And then we need to find dy dt. And gosh, we're going to have to rewrite that to be 3t plus 1 raised to the 1/2. So that's going to be 1/2 times 3t plus 1 to the negative 1/2 times 3. And I want to know dy dx at 1. So let's see, dy dx is going to be equal to, well, I'm going to go ahead and throw that 3/2. And then we have times 3t plus 1 raised to the negative 1/2. And that's all over 3t squared minus 1. So what's the value of dy dx at t equals 1? So let's do some substitution and see. Well, at 1, when I substitute in, I get 3/2. Woohoo! And let's see, if I plug in 1, I get 3 plus 1, 4. 4 to the negative 1/2 is actually 1/2. And then over, looks like I'm going to get a 2 in the denominator. So I have 3/2 times 1/2 times 1/2. And so that looks like I'm going to get 3/8. Answer choice B. All right, so for number 9. Number 9 looks like it would be an absolutely horrendous problem, but really we need to realize that we've made a U substitution and they're telling us what they want U to be. So that's pretty useful. And also notice that our answer choices, they're all in terms of U. So very quickly, let's check our endpoints because the endpoints are going to help us quite a bit on this. So notice all these being in U. So let's take this U and convert our endpoints. So the top endpoint is going to be 4 over 2, which is 2. So automatically that gets rid of answer choice B, and it gets rid of answer choice E. And so the other endpoint looks like it should work out to be 1, and it does. Okay, so the next thing we need to make sure is if U is going to be x over 2, then I know I'm integrating from 2 to 1 of 1 minus U squared. Well, darn, that didn't help us any at all because all of the rest of the answers have 1 minus U squared. Well, the other option is we have to deal with the x in the denominator. Now, U is x over 2, so if U is x over 2, I really need to solve for x. X is really 2 times U, isn't it? So that means where this bottom x is, I need to substitute in 2 times U, and that gives me answer choice C. Okay, and for the last one, we are given the position vector, and we are asked to find the acceleration. So we need the second derivative here. So let's take x prime, and that's going to be 2t, and then the second derivative is going to give me 2. So that's going to eliminate A and B. So now let's find the second derivative for y. So the first derivative, stuff prime over stuff, so that's going to be 2 over 2t plus 3. Well, all right, well, that's not too bad. Now, let's see, can that eliminate an answer choice yet? No, it doesn't look like I can get rid of anything just yet. Now, for the second derivative, we have to remember that we can write this as 2t plus 3 raised to the negative 1. So when I multiply down to the front, I have negative 2. And so automatically notice that we have negative 2 there. There's nothing else that has that negative value. So something's telling me it probably needs to be answer choice E, but let's go ahead and finish it out just to make sure. So I'd have 2t plus 3 raised to the negative 2 times the derivative of the inside. All right, so yeah, it looks like the right answer is going to be E. So if you're in a crunch, then that might be a good idea.